Greetings, boys and girls. In today's video, we are going to review fraction operations as we prepare for our test later on this week. Okay, let's look at the first set of problems. We're asked to estimate, it would help if I had the pen working. We're asked to estimate the sum or the difference. So they don't want an exact answer. I'm thinking to myself, if each of these fractions were on a number line, would they be closer to 0, 1/2, or 1/2? And then I'm going to add those together. So 8/9. 8/9 would be somewhere over here. So 8/9 would be about 1/2. And then 4/7. 4/7 is going to be somewhere over here. Ooh, does not look like a 4. So 4/7 is about 1/2. I know that because 4/8 would be equivalent to 1/2. So 4/7 is really close to there. All right? So now I'm thinking to myself, what is 1/2 plus 1/2? Well, that is 1 and 1/2. So my estimate in number 2 would be 1 and 1/2. Okay, now for the second one, I'm subtracting. Now I have 3 and 2/5. Well, I know 3 and 2/4 would be 3 1/2. And 3 and 3/6 would be 2 1/2. So 2/5 is really close to the 1/2. So I'm going to think of this as 3 and 1/2 minus, now I'm thinking about 5/8. Is 5/8 going to be closer to 1/2 or 1/2? Well, I know 4/8 is 1/2, so it's 1/8 away from 1/2, and it'd be 3/8 away from 1/2. So I'm going to think of 5/8 as 1/2. So now I have 3 and 1/2 minus 1/2, which would give me an estimate of 3. So the actual difference is going to be about 3. Okay, let's look at our last problem. I have 1 and 5/6. Well, I know 5/6 is just 1/6 away from a whole, and it's 2/6 away from a half, which would be 3/6. So the 5/6 is almost like another whole. So this is going to be about 2 wholes plus 2 and 2/11. Okay, now I'm thinking about 11ths. If I drew another number line, just so I can think about it. I have 0, 1 whole, halfway point. It's nothing halfway for 11, but if I thought about like 10, I know 5/10 would be here. But that's still like a ways off. It's 2/11. So 2/11 is going to be somewhere close to 0. So I'm going to just think of that as 2 and 0/11, which is going to be 2. So 2 plus 2 would give me 4. So my answer is about 4. Tried to do my squiggly lines. About 4. All right, and those were estimates. They didn't want the actual sum or difference. Let's look at the next set of problems. Here, it says use the least common denominator to write an equivalent fraction for each fraction. Okay, so I'm thinking of my multiples of 5 and my multiples of 10. So the smallest number they have in common, oh look, I just looked at my denominators because I'm finding least common denominator. Smallest number they have in common is going to be 10. So 1/10 is already written with a denominator of 10, but 2/5, I'm going to rewrite that so that it equals a fraction with a denominator of 10. I need to multiply 2/5 by something over something to get a fraction with a denominator of 10. Well, I know 5 times something equals 10 Oh yeah, 5 times 2. So I'm therefore going to multiply 2 times 2 because I'm trying to get an equivalent fraction. 2 times 2 would be 4. So now I'd have 4/10 and 1/10, and my common denominator was 10. My least common denominator was 10. I could have also written 50, but that was not the least common denominator. Okay? Now let's look at the next one. I have 5/6 and 3/8. So I'm thinking of my multiples of 6 and my multiples of 8. And I want to write down the smallest multiple they'll have in common. 6, 12, 18, 24, 30, 36. Let's do some for 8. 8, 16, 24. Oh, look. They both share 24. So 24 would be our least common denominator. But now I have to rewrite 5/6 as a fraction with a denominator of 24. So I'm thinking I have to multiply 5/6 by something over something so that it can have a denominator of 24. 6 times what equals 24? What about times 4? So then I'd multiply the 5 times 4 as well so that I can make an equivalent fraction. 5 times 4 would be 20. So then I'd have 20 24ths. And my other fraction, 3/8, let's see what that's going to be. So that has to be something with a denominator of 24. Thinking of multiplying it by something over something. 8 times what equals 24? Oh yeah, 3. And 3 times 3 would be 9. So I'd have 20 24ths and 9 24ths. Okay, I'm going to let you guys do this one on your own. You can pause this video if you still need to work it out. So in this section it says, use models or strategies to find the sum and difference. Write your answer in simplest form. Okay, I'm going to use common denominators. Okay, we've talked about that a lot in class, and this is a great way because if I try to use a model, my models may or may not look perfect, so it could throw me off. But using common denominators will work. So I have a 6 and an 18. And I'm thinking about 6's. 6, 12, my multiples, 18. I can get both of them to have a denominator of 18. Well, 11/18 already has it. But now I need to make 1/6 have a denominator of 18. I know 6 times 3 equals 18, so I'll multiply by 3 over 3. 1 times 3 is 3, so now I have 3/18. From here, I can subtract. 11/18 minus 3/18. That would be 8/18. And I know I can simplify because they both end in even numbers. My numerator and denominator end in even numbers. So I'm going to divide them by 2 over 2. And I'll have 4/9. Okay, 9 is prime, and 4, its only factors are 2, 1, and 4. So this is now in simplest form, 4/9. Okay? Let's look at 9. Need to have common denominators. So if I list my multiples of 7, I'd say 7, 14, 21, 28, 35. Ooh, that ends in a 5, so I know at least my 5s will be there. 5, 10, 15, 20, 25, 30, 35. Yep, that's going to be our least common denominator. So we're going to get 2/7 to have a denominator of 35. So I'm going to multiply it by 5 over 5, because 7 times 5 equals 35. 2 times 5 equals 10. And now I need 2/5 to have a denominator of 35. And so I know 5 times 7 equals 35, so I'll multiply 2 times 7, which would give me 14. Okay, now I'm going to add 10 35ths plus 14 35ths. And I get 24 35ths. Okay, now I'm thinking to myself, can I divide 24 and 35 by anything? If I thought of my multiples of 24, I would have 1, 2, 3, I'm saying multiples, my factors of 24, it's 1, 2, 3, 4, 6, 8, 12, and 24, and my multiples of 35 would be 1, 5, 7, and 35. So they don't have anything in common other than 1. So 24 35ths is simplified. Okay, I want you to do number 10 on your own. Remember, you can pause this video if you need to. Okay, let's look at this word problem. Mrs. Michaels bakes a pie for her book club meeting. The shaded part of the diagram shows the amount of pie left after the meeting. That evening, Mr. Michaels eats 1/4 of the whole pie. What fraction represents the amount of pie remaining? So I'm looking at the shaded part to see how much is left after the meeting. So there are 8 pieces and 4/8 are shaded. That evening, Mr. Michaels eats 1/4 of the pie, and we're seeing how much is remaining. So this is a subtraction problem. So we're subtracting 4/8 minus 1/4. So what I can do is I want them to have the same denominators. So 4/8 already has, the 8 can actually be the least common denominator, or I can even work backwards, because I know that 4/8 is equivalent to 2/4. Why don't I work like that? Okay, so I'm going to now change this to 2/4 minus 1/4, and that would equal 1/4, because they have the same denominators. I can just subtract my numerators. 1/4, and look, that was an answer choice. Some of you may have decided to stick with the eighths, and you would have had 4/8 minus 2/8, which would have equaled 2/8, and from here you would have had to simplify to get 1/4 as your answer, okay, because you would have divided by 2 over 2, and that also would have equaled 1/4. Either way, we would have gotten the correct answer. Okay, in our next problem, we see that Mario is painting his walls. He needs a total of 5 2/3 gallons of paint for the job. Guess what? He has 3 3/4 gallons of paint. How much more paint does he need? So when I'm saying how much more, I realize this is a subtraction problem. So we are going to be subtracting 5 2/3 minus 3 3/4. When I get ready to subtract, I need my denominators to be the same. Right now I have a 3 and a 4. So if I thought about my multiples of 3, I would have 3, 6, 9, 12. And if I thought of my multiples of 4, I would have 4, 8, 12. So they both can share that 12. So I'm going to first rewrite 5 2/3 so that it has a denominator of 12. So the 2/3 portion, to make it have a denominator of 12, I'm going to multiply it by 4 over 4. And I will have 8/12. So my new fraction is going to be 5 8/12. I'll be subtracting from that whatever I'm going to convert 3/4 to. So 3/4, I need that to have a denominator of 12. I'm going to multiply it by 3 over 3, because 4 times 3 equals 12. So I'll have 9/12. So my new fraction over here is going to be 3 9/12. All right, now I have 5 8/12 minus 3 9/12. Let's focus on the fractions first. 8/12 minus 9/12. Ooh, I can't do that. I'm going to have to regroup. Why? Because 8 minus 9, I don't have enough. I'm going to go to this 5. I'm going to take a whole away. So now that's going to be 4 wholes. Now when I take a whole away, I'm going to add a whole to my 8/12. Well, in a 12ths, 1 whole would be 12/12. So instead of 8/12, this is going to be 8 plus 12/12, which will be 20/12. So now I'm thinking 20/12 minus 9/12, that equals 11/12, and then I can subtract my wholes. 4 wholes minus 3 wholes equals 1 whole, and I'm going to put these two together, my fraction and my whole number, for my answer. So I will get 1 11/12, which is answer choice D. 1 11/12. Press pause if you need some more time to work it out. Otherwise, we're going to move on to the next section. This time, we're dividing, and we can use a model. Now, some of you probably don't feel that you need to use a model anymore. But you're thinking of 3 wholes, and you're seeing how many 1/2 size pieces will you have. Well, there's 1, 2, 3, 4, 5, 6. 6 total pieces. Okay? I'm going to look at 4. This time, you have 1/2, and you're dividing it by 2. So you want this to be broken into 2 more pieces. So now we're thinking, how much is this one section? Well, if this is a whole, that one section represents 1/4. All right, boys and girls, you can do the next ones on your own. If you feel like you do not need a model, you don't have to use it. Feel free to press pause on this video so that you have time to solve these. Otherwise, I'm going to move on to the multiplication problems. Okay. In these examples, we're multiplying a fraction by a whole number. Remember, when I multiply a fraction by a whole number, I can rewrite the problem by putting my whole number over 1. So I can think of this as 2/3 times 6 over 1, and then just multiply straight across. 2 times 6 would be 12, 3 times 1 would be 3. I need to simplify, because it says write it in simplest form. 12 divided by 3 would be 4 wholes. So that answer would be 4 wholes. Okay, I'm going to also look at 11. I'm going to rewrite 2 times 3/11ths to be 2 over 1 times 3/11ths. And when I multiply straight across, I'd have 2 times 3, which is 6, over 1 times 11, which is 11. And I can tell you 11 is a prime number, and the only factors of 6 are, other than 1, are 2, 3, and then 6. So this is in simplest form. Okay, you all can do the remaining problems on your own. You can use the model if you need to. Otherwise, you can just solve using the math. Press pause on this video if you need more time. All right. We have a couple of word problems to end this program, this homework video. 15. Holly had 30 pencils. She gave 6 pencils to her friends. 3/8 of her remaining pencils need to be sharpened. How many of Holly's pencils need to be sharpened? Oh, wait a second. She had 30. Then she gave away 6. So it's like subtracting 6. So that means she had 24 left. Then they tell me 3/8 of, ooh, look at that. So when I see 3/8 of, the remaining is 3/8 of 24. This is a multiplication problem. So 3/8 of 24. I'm going to rewrite that as 3/8 times 24. I'll put it over 1. I'm going to simplify first. And what I mean by that is I'm going to go diagonally and simplify before. Because I know that 8 goes into 24 3 times. So I'm going to change that into a 3. I'm basically dividing 24 by 8 and 8 by 8. So that would be 1. Now I have 3 times 3 over 1 times 1, which is 9 over 1, which would be 9. 9. If I did not do that step, I would have had to do some long division. Or not. I could have had 3 times 24, which would have given me 72. And then that would have been 72 over 8 times 1, which is 8. And you guys could have also seen that answer is 9 wholes when you divide 72 by 8. Last question. Thomas makes 5 sandwiches that he cuts into thirds. How many 1/3 size sandwich pieces does he have? Okay, so I'm taking the whole amount. I am dividing it, because I'm cutting it up into thirds, so I'm dividing it by 1/3. So when we're looking at 5 divided by 1/3, we can think of it as keep the 5, change the division symbol into a multiplication symbol, and then flip. In 1/3, write the reciprocal, which would be 3 over 1. And then I get 5 times 3 over 1, which is 15. 15 pieces. Boys and girls, I hope that with our review today, this made you feel a little bit more confident about the test that we're going to take on Friday. Until we meet again, take care. And by the way, if you still need more practice, check out my website, victoriajpayne.com/class, because under the weekly resources, you will see some Khan Academy practice links and some other iExcel practice links to help you still get it, plus some really cool songs on fractions. Take care.